So we're going to pick up now with our second set of lectures on human memory. In this set, we're going to cover a bit more detail about working memory and also long-term memory. So the learning objectives for this set of lectures is that by the end of this lecture, it's my hope you'll be able to, one, describe the basic properties of working memory, to explain different theoretical models of working memory, three, differentiate working memory from long-term memory, and four, explain how new long-term memories are formed and how competing long-term memories are correctly retrieved. So we should be able to get through objectives 1 and 2 in this lecture, and then in the next part, we'll talk about working memory, long-term memory. So we'll get to parts 3 and 4. So working memory. Working memory is often referred to as short-term memory. And this is the temporary maintenance of a small amount of information useful for performing cognitive operations. Now that definition was quite a mouthful, and so we're going to break down some of the terms in that definition. So temporary. Temporary just means that information that's held in working memory is only being held for a very short period of time. So a very short duration. Small amount means that the information that can be held in working memory is limited. We can only hold a few bits or chunks of information in mind at one time. And this notion that it's useful means that working memory, or short-term memory, aids with doing other tasks of cognition. So some examples of encountering working memory in everyday life. So say it's not 2020 and you have to remember a telephone number. So someone tells you their number and you have to remember it long enough to be able to enter it into your phone. Again, this scenario probably wouldn't happen in this year or in most of our lifetimes now, because obviously you could just get their number in your phone right away. But it used to be the case that people would have to remember it for a longer period of time. We're just trying to keep in mind 3 to 4 steps for a recipe, for example. So instead of having to toggle back and forth between maybe the instructions are on your phone, maybe trying to hold 3 of them in mind at a time so you can just repeatedly go through those steps. Or you can think about when studying for a test, for example, you might need to rehearse information or learn new information. You might be trying to learn quite a bit of information at one time. So working memory is involved in everyday life in quite a lot of different situations. Now, as I mentioned, working memory holds information for only a short period of time. Usually, when you see the term short-term memory, you think of things that have transpired in the past day or so, maybe even in the past week, but that information is actually being held in long-term memory. So the storage of that information is no different than the storage of information that might have happened a year ago or 2 years ago. It might be that that information is more sharply defined just because it occurred more recently, but there is no distinction in terms of whether that information versus information from a year ago are being held in different systems. They are not. They are both already stored in long-term memory. So I point this out because a lot of times if you tell somebody that what happened yesterday is actually in long-term memory, they'll think, well, that's short-term memory. But working memory actually operates over a very small time frame, usually within about 1 to 30 seconds before information is either forgotten or carried on into long-term memory. And so information is held in working memory for a short period of time. It either stays in working memory or it's pushed out. It could be pushed out into long-term memory or it could be pushed out and just forgotten altogether. And this implies that there is interference between information that's being held in working memory and new incoming information. So if you're processing information from the environment, that information might interfere with stuff you're already storing in working memory. And working memory has a very limited capacity. In fact, it's restricted to only about 3 or 4 chunks or bits of information at a time. And because of this, information competes for maintenance, so it competes to be held in working memory. And if you try to process new information, so new information is coming in from the environment, this might cause you to forget the information that's already being held in working memory, or you might not be able to register that new information. So to combat this, information that is currently held in working memory has to be moved into long-term memory. And the mechanisms by which this happen fall out of different theoretical models of working memory, which have developed over the years. And the first of these models was the AtkinsSchifrin Model, which originated in 1968. And here's just a visual illustration of this model. So we begin with input. This is stimuli from the environment. Sensory information, it could be verbal, it could be visual, it could be a combination of both, it could be haptic or touch related information. Regardless, there's some input from the environment, and that filters first into sensory memory. And sensory memory is a very short-term storage of information. It's so short you wouldn't even really be able to draw conscious attention to it. Because actually, attention moves information from sensory memory into short-term memory. So short-term memory, highlighted here in yellow, that's your working memory component. Some information that goes from the environment into sensory memory is forgotten right away, but some passes into short-term memory. And information that's held in short-term memory can then be rehearsed or moved into long-term memory. So you might try to rehearse that information, maybe by saying it to yourself multiple times. This might be some kind of strategy you use maybe when studying for an exam, especially if, for example, you're learning a new definition and you're just trying to rehearse its meaning over and over again with the idea that this will move it into long-term memory. Once information is encoded from short-term memory into long-term memory, that information can then be retrieved back into short-term memory. So if you were studying for a test, for example, and you were rehearsing this information, and you ideally did move it into long-term memory such that the next day when you actually take your test, you're able to then retrieve that information back into short-term memory long enough for you to be able to successfully answer a question on your exam. However, at each processing state, so in sensory memory, in short-term memory, and even some information from long-term memory can be forgotten. So some of the information will not be stored permanently, especially vulnerable in sensory memory and short-term memory. Now from this model, the next model is the BlairHitch Model, which you may have encountered in some other classes. And this just came about 6 years after that one. It's actually just a slight variation on the AtkinsSchifrin Model. It retains the same basic structure. So there's some input, some stimuli from the environment that pass into sensory memory. Some of this information decays instantly, but some, through an attentional process, is brought into the central executive. So the central executive is actually a module. It's a part of short-term memory, a part of working memory. But what the central executive is doing, and this is new, this is unique because this was not included in the AtkinsSchifrin Model, the central executive then allocates that new incoming information to either a visual sketchpad, if the information is visual in nature, or to a phonological loop, if that is acoustic or that is auditory information. So basically what the central executive is doing is it's separating information from different sensory modalities. And the idea is that information that's visual should then not interfere with information that is auditory. These two sources of information should be kept separate. And then information from either the visual spatial sketchpad or the phonological loop could be passed on to long-term memory and then later retrieved back into the central executive. So again, it shares some of those same features that the AtkinsSchifrin Model had. Finally is the Cowan Embedded Processes Model. And Cowan, that's actually a professor here in our department, Nelson Cowan. So this model came about 14 years later, and this is referred to as the Embedded Processes Model. And it's slightly different from the other two models in that it does not propose a separate working memory from long-term memory. Rather, it assumes that working memory is a subset of long-term memory. So we have all this infinite knowledge that we accumulate across the lifespan. So that's this white box, this long-term memory box. And incoming information comes in from the environment and it activates a subset of long-term memory. Basically, this helps us to connect to the new incoming information, old information that we already know. And so we'll pick up right there in our next lecture.